Today I am going to explain some practicals of the digital signal processing subject. The first practical is write the MATLAB program for linear convolution of two given sequences. The second practical is write the MATLAB program of circular convolution of two given sequences. And the third practical I am going to explain is that write the MATLAB program to find impulse response of the following system. In this, one system is given to you and you have to define the impulse response for it. So the system is given to you like this: y of n equals to x of n plus 0.5 x of n minus 1 plus 0.85 x minus 2 plus y of n minus 1 plus y of n minus 2. The first practical today I am going to explain is write a MATLAB program for a linear convolution for two given sequences, right? So for that, first of all, we will start with this MATLAB. In this, first of all, we take it to new. In this one is the additive file. In this, we can add it to instructions, right? In this, first of all, we start with the first instruction, which is CSC. CSC means clear command window, and the next instruction we will start with is clear all. It means it will clear all the other values other than this additive file only. Now the next instruction is close all, means it will close all the other files, only just this additive file will open. Now the next instruction is, first of all, we have to do the linear convolution, right? So for that, first of all, we have to take two different sequences. Two input sequences we are taking is like, suppose if I am taking the input sequence 1 as A and the input sequence 2 as B, then we will performing the linear convolution on these two input sequences A and B, so it will give you the output in the C. So for that, first of all, we will start with the instruction A equals to, we are defining the first input sequence. So for that, we will taking the instruction as input in the bracket single inverted comma, we will taking that enter the input sequence 1. So it will give you the first input sequence. Now if you want to plot this, so for that, first of all, if you are taking that this is the discrete time sequence, so for that we have to use the instruction as step. So for that I am taking the instruction as span A. So we will plotting the input sequence A in this. Now we have to save this file and we will running this file. So it will ask in the command window as enter the input sequence 1. So in this we will enter the input sequence in this bracket. Suppose if I am taking input sequence as 1 is 2, then it will give you the output like this. First input is 1 and the second input is 2, right? So this one is the graph of this input. Now same way we have to define for the second instruction for the second input. So for that I am taking this same as the input B. So it will consider as B equals to input, enter the input sequence 2. And in this we have to plot the second input sequence, which is span B. Now suppose if I want to draw both the input sequence parallelly, then for that we have to use the subplot. So basically subplot will divide the whole plot screen in the number of parts. So if I want to take three different graphs, the first one is for the input sequence 1, for the second graph is for the input sequence 2, and the third graph is for the output of the linear convolution. So for that we have to use three different rows and one column, right? And in this we will taking three different positions. So for that I am using the instruction subplot before the plotting the sequence. So I am taking the instruction as subplot 3 rows, 1 column, and on the first position I am going to plotting the first input sequence A. Same way, if you want to plot on the second position the second input sequence, then I am writing subplot 3 rows one column and third position, then it will gives you the output. So when plotting the output sequence as T, so it will gives you the stem T. So if I am running this program, so it will ask for the first input, which is 1 and 2. It will gives you 1, 2. Next, if I am taking second input, it will gives you the 1, 2, 3, 4 as we have taken. So it will gives you the output T equal to 1, 4, 7, 10. And if we see in the output, you can see that 1 and 2 is the first input sequence, 1, 2, 3 and 4 it is the second input sequence. So it will give you the output as a 1, 4, 7, 10 and 8. So this way we can find the linear convolution by using the MATLAB program. If you want to give the title of this each and every graph, then you have to use the instruction as title, bracket, single inverted comma, then applying the title to the given. Same way, if you want to apply X label and Y label, so for that we use the X label and Y label. So suppose if I am starting with this X label, linear convolution of sequence. So if I am running this three term will occurring in the third graph only, right? For this two graph we have to write this again. So here I am taking only for the output. So if I am plotting this, then in the output it will gives you this title and X label, Y label. You can see that in this X label is given to as time, as we had defined X label as time and Y label as amplitude. So here it is representing as amplitude and title we had given is linear convolution of sequence. Same way we can also define for this two input sequence also. Now the next practical is we have to do the circular convolution of two given sequences. So for that I am taking the another editor file. In this we'll starting with clear C, clear all and close all command. Right. Now what is the basic difference between linear convolution and circular convolution? In this two convolution type, in circular convolution the length of the two sequence will be same. If it will not same, then we have to do the same length of input sequence. So we'll starting with defining the input A. A will be defining as input next we'll defining the length of this input sequence 1 and 2, because as I have told you that in the circular convolution the length of these two sequence would be same. So for that we'll defining the length of the first input sequence is n1. So n1 equals to length of A, and if we're defining n2, then n2 will be defining as length of B. Now, if in the first input sequence there will be two terms only, and if in the second sequence if there will be four terms, then we have to do four terms. So we will finding maximum value of number of terms. So it will defining as n equals to maximum of n1, comma n2. Now we are comparing the two input sequences. N1 is greater than N2, suppose, then it means N1 is greater. It means it will consider as the input sequence X. A will be greater than the input sequence B. So we have to add number of zeros in the input sequence B. So we will using the instruction as B equals to B comma zeros 1 comma n1 minus n. So what is the meaning of this? In this we are defining that in the B we will adding number of zeros, 1 row and number of columns means n1 minus n2 means the difference of two input sequence length. So we have to add, suppose if I am taking input sequence of 4 different terms and in the input sequence 2 only 2 terms, so we have to use 4 minus 2 means we have to add 2 zeros in the input sequence 2. Same way, if the another possibility is there, then it is considered as else. It means n1 is less than n2, then we have to add in the a. So we are writing like this: a equals to a comma zeros. In this we are using the difference as n2 minus n1. Now ending this if instruction. Now we have to subplot these three input sequences, right? So we're using subplot zeros, 1 column, and on the first position we have to plot the input sequence 1. So I'm writing like this: plot A. Same way, the next is we're using subplot zeros, 1 column, and on the second position I am plotting the second instruction. In this we have to use stem instruction, right? So I am writing like this. So for first instruction, if you want to draw the first instruction, so for that I am drawing this first instruction as stem A. Now if you want to draw the second sequence, then for that I am using subplot P1, 2. In this I am taking stem B. So first and second input sequence will be drawn. Now we have to find the output. If you want to find the circular convolution by using FFT method, then for that first of all we have to take FFT of two input sequences, then we'll multiply this two, and then we'll taking the inverse FFT of it. It means we'll taking the Fourier transform and then we'll taking the inverse Fourier transform. So for that, first of all I am taking the first output which is y1, so it will consider as FFT of a comma n. So it will give you the FFT of the first input sequence. Similarly, I am taking y2 equals to FFT of b comma n. Now I am taking the multiplication of this two. It will be stored in the y3. So value of y3 equals to y1 into y2. Now we have to take inverse Fourier transform of this, which will give you the final output of circular convolution. So for that we will take y equals to inverse FFT means I FFT of y3 comma n. Now we have to plot this graph. So for that I am using subplot zeros, 1 column, and on the third position I am going to draw this graph. So in this we have to plot this. So for that I am using Now the next practical is we have to find the impulse response of the input sequence. So if you want to find the impulse response of the given input sequence, so for that the input sequence is already given to you as y of n equals to x of n plus 0.5 x of n minus 1 plus 0.85 x of n minus 2 plus y of n minus 1 plus y of n minus 2, right? So if you want to perform this, then for that, first of all, we'll starting with clc clear all and close all command. Now for this, we have to define two input coefficients. So for that, I am defining the first input coefficient, which is if we're taking the coefficients for input x, then it will defining as constant b, and if we're defining the coefficients of output y, then it will defining as a. So in starting with this b equals to input and basic coefficient of x, input x. Now the next is we will defining the coefficient of y, which will be stored in the a. So for that we will use the instruction as input and the coefficients of y. Now when defining the length of it, it will be defining as n equals to input and enter the number of samples of impulse response. Now, if you want to find out the impulse response, so for that we use the instruction as impulse. So for that we using the instruction as impulse response will be defining as x of t. So for that it will give you the two output as h and b. It will find by using the instruction as IMP, that means impulse response. For that we have to apply the coefficients of input x, coefficients of output y, and the length of the impulse response. So if we giving this, then it will give you the impulse response. Now if we want to plot this, as you can see that this one is a continuous time signal h of t. So we'll using the plot instruction, in which we'll applying the plot of on the x-axis we'll taking t and on the y-axis we'll be plotting the h. So it will give us the output of this. We can also apply x label, y label, and like this. Then I am running this and we will ask that enter the coefficient of x. So from the term, the input coefficient of x will be 1, 0.5 and 0.85, right? So it will ask for the coefficient of y. In this we have to apply the coefficients will be 1, -1 and -1, because y of minus 1. Y of n minus 1 and y of n minus 2 is on the right. So we'll applying this to coefficient. Now it will ask for the enter the number of samples of the impulse response. So if you want to find the first five samples, so I am taking 5 samples, so it will give you the output like this. So it will plot for the first 5 samples and it will give you the impulse response of t. So this way we can find the impulse response. Thank you so much.